Pacific, BITS Pilani, and Civil Constructional with All India Radio. Professor Bansal has significant experience of collaborating with industry and government organizations. He has made significant contribution to the development and delivery of PS and ME programs for utilities. He has extensive experience in the design and delivery of CPD programs for professional engineers. He has carried out research and consultancy and attracted significant funding from industry and government organizations. Professor Bansal has published over 300 journal articles, presented papers at conferences, books, and chapters in books. He has Google citations of over 10,000 and H index of 44. He has supervised 22 PhD and 4 postdocs. His diversified research interests are in the areas of renewable energy and smart grid. Professor Bansal is an editor of several highly regarded journals, IET, RPG, and IEEE Systems journals. He is a fellow and chartered engineer IET UK, fellow Institution of Engineers, and senior member of IEEE USA. Now I request to Professor Ramesh Bansal sir, please start the session.
Good morning, everyone. My voice is clear and audible, please?
Yes, yes, sir.
Okay. So it is my pleasure to deliver lectures on this AICT sponsored program on the automation and control for the industrial systems. I would like to thank Professor Bhardwaj for extending his kind invitation. I have been knowing Professor Bhardwaj maybe more than 10 years or 15 years. So he approached me and I agreed to deliver several lectures for this program. In fact, when we talk about the industrial automation, I was giving a thought that, what topic it can be considered. Then I give a thought that, which industry could be the largest or biggest one. Okay, which sometimes we may not think that it is like an industry. It is the industries of industry. All industries will depend upon that. Like the electrical industry, power industry, how the electricity is generated, transmitted, and distributed. Okay, so economy of any nation will depend upon how good is the electrical power system. So I thought to give a good, uh, lecturing on this like electrical power industry. So I will just share my presentation. All right, so I hope my presentation is visible, please.
Yeah, it is visible.
Okay, excellent. So uh, I will be presenting the topics like the automation and control for the conventional power systems, automation and control for diesel generators, automation and control for photovoltaic systems, automation and control for renewable power systems and drives, then automation and control for hybrid power systems, microgrid, and smart grids. Okay, so you have already been provided the presentation schedule, that today we have the presentation on automation and control of the conventional power system. Okay. Then tomorrow we have the automation and control for diesel generators. We have two lectures tomorrow. So automation and control of diesel generators, automation and control of photovoltaic systems, I briefly touch upon the distributed generation in this topic as well. Then on 18th, we talk about the automation and control for wind power systems. Then on 19th, I talk on the automation and control of hybrid power systems, microgrid, and smart systems. In fact, I speak on diesel generator on the 16th. So briefly, I talk about the diesel generator. Then if you see the application of diesel generator you can find in the buildings as the standby generators or backup generator, and then diesel generator will also be used in the renewable systems, what we call as the hybrid power system. In the hybrid power system, like we have this wind photovoltaic system in parallel with diesel generator. So generally diesel generator will have the two applications. So here on 16th, I will just briefly touch upon the diesel generator to maintain the same sequence. And then on 19th, I talk again diesel generator when we are talking about the hybrid systems, microgrid systems. So here on 16th, when I touch briefly about the diesel generator, then I talk more about the photovoltaic system. So just to keep the same sequence, same program, but depending upon the importance of topic, probably I think it is fine that, if one topic is completed, so I can start with the next topic. Dr. Bhardwaj, it is fine, I think.
Yes, sir.
Okay, so we have, I believe, slightly flexibility. If some topic is lengthy, I can go more time, but of course I have to cover this in the given schedule. So without taking much time, we will start with the conventional power systems. Conventional power system, you will see that basically we have the different types of conventional power plants. Fossil fuel based power plants, which comprise of coal, gas power plants. Then we have large hydro and nuclear power plants. So we briefly talk about the conventional power plants. When we talk about the fossil fuel, basically coal-based power plants, so what are the major issues? Major issues, as we know worldwide, is because of the lot of CO2 emission. Okay. So because of that, we are moving towards the renewables. So to give you broader picture, you understand the situation. Okay. So I know that uh, participants may be the diverse background from electrical, mechanical, and some other discipline. So I'll try to go slow and try to explain the concepts in the simple way. But feel free to ask any questions or any part you don't understand. Okay. So when we talk about the structure of power system, so this power system basically three we can divide the power system in the three parts called as the generation, transmission, and distribution. These three aspects, in fact, very large. Okay. So you may see that several years earlier, worldwide deregulation of the power system started to introduce the efficiency in each sector, generation, transmission, and distribution. Because to handle all these three aspects, generation, transmission, and distribution, by one company, it is really very challenging task. So you may see that on on the different states, so these three systems, generation, transmission, and distribution were separated. You may see the names like the Genco, Transco, and Disco, just with the objective to improve the efficiency of each sector. And wherever there are problems, these can be rectified and corrected. Okay, so we have the generation of electricity through the large scale power plants in terms of coal based, large hydro, nuclear, gas power plants. Okay, as I mentioned, in recent time we have got the issue of uh, lot of emissions from the conventional power plants, fossil fuel-based power plants. So we are moving towards the renewables in terms of wind photovoltaic system. The trend is worldwide. Okay, so the renewables will be integrated in the power systems, generally depending upon what size of renewable power plants are there. Depending upon the size of the power plant, they can be integrated in the distribution system, or if they are of the significant size, they can be suitably integrated in the transmission or sub-transmission system. So we have generation of electricity, then depending upon how much distance we want to transmit this power and how much is the amount of power. So accordingly, we will select the suitable voltage level. So what will be the voltage level? The generation of electricity will be normally between the voltage 11 kilovolts to 33 kilovolts. 11 kilovolts means 11,000 volts to 33,000 volts. Then the transmission, the voltage will be stepped up by means of the device called as the transformer. So the transformer is extremely important device in the electrical power system, which can increase or decrease the voltage level depending upon the requirement. So if the transformer is increasing the voltage, we call this transformer as the step up transformer. In the distribution system, when the transformer is stepping down the voltage, we call this transformer as the stepping down. Okay. In fact, this topic itself is so vast, so large, it cannot be covered like in lecture or so. There are several uh, complete courses on the power system to talk about the generation, transmission, and distribution. So I'll just try to give you some key and important aspects. But anyone interested in more, so they are welcome to ask some more reference or get your queries clarified. Okay, so we have the basically generation, transmission, and distribution of electric power system. Now you will see that in a country like a large country like our Indian power system, so there will be thousands of generating plants. There will be uh, huge transmission networks. If you combine all the transmission line for the different voltage level, its length will come in the lakhs of kilometers. Okay. Then, of course, we have the distribution system, residential, industries, commercial sectors, etc. Now here, like we have our generation system, then the load on the system, it will not stay constant, but the load will keep on changing. The electrical power system is very dynamic. Okay. So how much is the demand of power? So demand of power in electrical power system, because this quantity is very large. So the unit we use for the real power is called as the smallest unit is watt. So we say if the electric bulb is rated as, for example, 100 watt. So smaller unit is watt. If you go bigger unit like this heater, we can say 1 kilowatt. But in the large power system, we have the unit after this kilowatt, we have megawatt, and bigger than megawatt, we have the gigawatt unit. So the demand in a country like our country, of course, the demand will be in gigawatt. So this power demand, if you plot this demand with respect of time, we call it as a like the daily demand. So this daily demand on power system, it will not be constant, but it will keep on changing as the time changes. During midday, demand can be less because uh, people go to the work, residential, load is less. Then in the evening, demand can be more. Then during the night, during late night, it can reduce. So basically, the power demand keep on changing throughout the day. Then if you consider the seasonal variations like the summer, winter, spring, so this power demand will keep on changing because we have the different types of load, air conditioning load during the summer, winter we may have heating load. So basically this demand will keep on changing throughout the day, throughout the season. So when we plot the demand with respect of time. Time could be like day, or it can be week, month, or a year. Okay. So this power demand keeps on changing. So this power utility have the obligation to supply the power throughout the day, throughout the year to the whole community. So this power demand is changing. Okay, so it becomes a very challenging task. It is not only just supplying the power to the community, but supply the power in the economical way. Okay, so and you know that there will be different types of power plants: coal-based power plant, gas-based power plant, hydro power plants, nuclear power plants, renewable power plants. All are integrated. So the how the load should be made, or when we define the demand of the electrical system, the demand of the electrical system can be further classified as like in three parts. One, what we call as the base load, then intermediate load, and then we call as the peak load. So as the name indicates, this for example, base load is that this load will stay throughout the year. Okay, even if we have any time during the day or any season, so this load will be there. Intermediate, this load can vary according to seasonal level. But some part of the time, there can be what we call as the peak load. So this will occur, peak load will occur in a year just only few days. Peak load will occur just only few days, but even we have the peak load. So this peak load has to be also met. Okay, for example, if you have this festival season, Diwali season, so suddenly load increase in that particular week. So again, we cannot keep the people in the dark. So that load has to be also met. Now we have got the different types of power plants: coal-based, hydro, nuclear, and renewables. So if we have to maintain for the base load, which type of power plant could be best suited? So this plant will run throughout the year. So basic objective here is that any type of plant which can be less costly. Okay, so good example could be if we have the large hydro, sufficient large hydro. So that could be the best option. It will cause minimum pollution, and it will be less costly. So for the base load, the large hydro can be a good solution. Now, for the even like for example, if we do not have the sufficient large hydro, then of course we may need to consider other types of plants. Can be nuclear or can be coal-based power plant. Then intermediate stations. Again, the intermediate maybe slight bit requirement could be in terms of how quickly the power plant can be started. Particularly, for example, when we talk about the peak demand will come just for very short duration of time. It can come for a few days or during any time of the day. Suddenly, the peak demand will come. So the electrical system is most automated and control system. So it is whatever the demand comes on the power system, we have to meet in the real time. Okay, the demand is this instant, so same instant the demand should be met. So the electricity is the most fresh commodity. Okay, if you have food, we can store for a few days and consume as per our requirement. But electricity is the most fresh commodity we generate and consume in the real time. So there has to be almost perfect balance between the generation and demand. We cannot uh, store the electricity in bulk quantity. Storing of the electricity in bulk quantity is a very challenging and costly task. So different types of generators, generating plant have the time requirement. For example, if I talk about the coal-based power plant, coal-based power plant. So if you have to start the coal-based power plant, maybe coal-based power plant can be the condition what we call as the uh, in the cold start, when the power plant has been closed for several days and you are starting. So you have to bring the plant in the hot condition. You have to bring the condition for production of steam, and it can take, say for example, 4 hours to 8 hours or even more to start the power plant. Now the gas-based power plant, gas-based power plant, its starting and taking of the load can be very fast. Okay, so the how much time the power plant will take to start. I give you another example. Like for example, we have the different cars, okay, or say bike. Some people will like that, on the red light, bike stop. And what is the speed pickup? Just in few seconds, speed pickup from you know zero speed to say 60 kilometer per hour or 100 kilometer per hour, just like in less than a minute. Okay, so same concept is applicable here in the power plant. Okay, because the automation and control involved is huge. I will explain you. If the ramp rate is basically how fast the load can be taken by the plant. Okay, so this is very important in the electricity environment for operation of power plant. So during the peak demand, we are not worried if the power plant which will operate during the peak plant, it will be costly or less costly. But automation and control is very important because peak load comes for short duration of time, and electricity we have to match in the real time. So the power plant which has to be operated for the peak demand, the plant should be able to operate instantly within few minutes or so, and it should be able to take the load. The good example of this for the peak demand is like a gas-based power plant. Gas-based power plant, it can be slightly bit more costly, but doesn't make difference. This plant can be started and load can be taken by the plant very promptly. Okay, so the classification and understanding for these different types of the plant is very important. Just to briefly explain you that we may have the different types of plants, as I mentioned. You can have, for example, a coal-based power plant, or you can have the like fossil fuel oil or gas-based power plant. Now, where these plants should be located? Is there some flexibility where the plant should be located? And of course, we have the load center, what we call as the urban centers, big industry, city, suburbs, etc. So generally, the coal-based, the coal will be taken from the mines which can be located, like for example in Bihar or some other states. Load is located in the NCR. So where the plants should be located. Okay, so this here this T stands for like the fossil fuel thermal power plant. This is the example of hydro. This is the example of nuclear. So here in coal-based power plant, you can have two options. You can have the power plant close to the where the coal mines you have. Then you have to transmit power through the long transmission line. Or you have the options that coal is coal is transported through railway lines to the power plants. Okay, so there can be two options. There might be flexibility associated with the coal-based power plant where you would like to uh, have this coal-based power plant. Then, of course, you can have these power plants based on this oil or gas power plants. So this gas will be extracted from the sea, and the gas turbine will be operated based on that. So where the plants should be located, and then of course we have the, for example, hydropower plant. In hydropower plant, we do not have the flexibility that where you would like to install the power plant. Obviously, wherever we have this uh, the waterfall, where we construct the for the large hydro, we construct the dam. So plant will be located close to the dam. You cannot have the large hydro like near the metro city. Wherever we have the dam, plant will be obviously constructed there, and power will be transmitted, of course, through the long transmission line. But for the other power plants like the coal-based power plant, there can be flexibility where the plant can be located. It can be close to the city. Of course, we have to keep in mind that about these pollutions and other issues around that as well. Then, of course, we have the nuclear power plant. Nuclear power plant. The major issue with the nuclear power plant we see is the how we have the nuclear material can be activate after several years. So there are concern on the safety and security. We have to be careful about that. So this I just give you brief idea about the location and the different options for the uh, uh, large power plants. Okay, now this comes the extremely important aspect of the power plants. In a power system network in a country, different power plants, large number, thousands of power plants, hydro, nuclear, fossil fuel based power plants. So in every power plant, will be appropriate type of control. So just to give you example, this is your hydro power plant. This is your fossil fuel coal-based power plant. This is your nuclear power plant. Now, whatever the electricity we are generating, the electrical power, what we call, is basically we have this three terms I will try to explain, that we call it real power or active power. Another power we call it reactive power, and then phasor sum of real and reactive power we call as the apparent power. Real power is basically what we call as the actual or real power. So real power will be generated, for example, if you talk about the example, real power will be generated because of burning of the coal. So if you are burning more coal, we are producing more real power. So basically, you can say real power is related with the fuel input. Fuel could be in terms of coal, it can be in terms of nuclear material, or it can be the water input. Okay. What is this reactive power? Uh, I hope everyone understand the reactive power. Reactive power is required in the power system to magnetize the systems. We have the windings, we have to magnetize the circuit, we have to create the flux in the electrical systems. So for that, reactive power is required. So reactive, there are different, uh, you know, devices in the systems which generate the reactive power, and there are the devices which consume the reactive power. Okay, so for example, uh, the inductive load, your loads mostly comprising of induction motor, that will consume the reactive power. Then the systems like the generator, which can supply the reactive power. Transmission line can also supply the reactive power. Cables can also supply the reactive power. So there has to be a proper balance for the real power generation and real power demand. There has to be proper balance between the reactive power generation and reactive power consumption. So in real time, this has to be balanced. Okay. If this is not balanced, so what consequences will happen? I will explain in the next. So here, all these different generating plants, they are interconnected through the transmission network. Okay. So if we see the control for any individual generator, individual plant or generator, there will be appropriate control, like you can see here in the coal-based power plant, there is control for the steam through the steam wall control. Even if you have this nuclear, we have similar control. If you have the large hydro, so there is control for the passage of water through the hydro turbine. Okay. So this control is very important. Now, as I mentioned, that our power system network is interconnected. We have the thousands of generators. So all these generators are interconnected. Okay, our power system network is interconnected. So why this is interconnected? How it is interconnected? What are the advantages for this interconnection? So here, this this power system network is interconnected through the transmission lines, what we call as these lines as the tie lines. Giving the example, like these three power plants are there. So these are like the individual generation transmission load, but they are interconnected. Interconnected, what will be the advantage of the interconnected? That your stability of the power system, reliability of the power system, and economy of the power system will be there if the system is interconnected. Why the system will be stable? If there is more load in a in an area, that particular generation will not able to supply. The additional power can be supplied through the another power plant if it is interconnected. Okay. If the failure occurs in one generating station, power can be supplied through the another generating station if it is interconnected. Then if the system is interconnected, there is economy in the system. How it is economical? Because if we see that there is large, you know, availability of hydro dams are full. Okay, so if the system is interconnected, so significant part of the required power can be supplied through large hydro. We can minimize the generation from the coal-based power plant. So the system can be economical if it is interconnected. So our power system slash system is obviously interconnected. So there are several advantages associated with that. Okay, now if we talk about the how this in a nation power is controlled, there are several load dispatch centers at the central level and regional levels, so which will control the power. Even if you see in any individual power plant, there will be a control room as well, which will control the power generated in the power plant. So here you can see that how the power will be controlled and supplied. If we talk about the individual power plant, so this type of control room it is an example of all type of power plant. If you see the power plant maybe 20 years 30 years old, you may see the control systems control room like what it is appearing here. Okay, if you see the modern power plant recently built up or recently renovated, so control system you'll find it quite different, because this course talks about the automation and control. So I will explain this point very clearly, that whatever the advancement it has taken place, uh, some student raise their hand maybe if they want to ask question, or maybe
Professor Bansal, the question hours will be in the last.
okay,
So,
good.
You finished at 11:05 or 11:10. Then
Okay, good.
questions will be answered.
That's good. So here the control, whatever the development it has taken place in the electrical power system. So most of the machines, generators, basically there is not much development. The development is quite saturated. But whatever we see is the development is mainly in the automation and control. Okay, so the huge development has taken place and taking place in the automation and control. If you see the an old power plant, you'll see the control room quite big, large number of meters are there, can be separate panel for the electrical control, mechanical control. Different parameters will be observed and controlled. Okay, I worked long back during uh, around 88, 89 in the Delhi Electric Power Supply at that time used to call as the DESHU. Okay, so if you see the control room at that time, we used to sit in the control room. If we have to control boiler steam or do any operation, what will we do? You can see the people in the control room, they will speak with the operator on this walkie-talkie phone. You'll say, okay, increase the steam ball, increase the temperature, increase the pressure, control the uh, mills for the call process. So basically, most of the operation will be either through the plant itself, operator will be doing, or some of the operations will be done in the control room through the different switches you are seeing. Okay, so this used to be the old type of the control. Okay, but what we have the now in the modern power plant, so most of this control system has been automated. If you see the control system of a modern power plant, you will not see this like the large panels, but simply what you will see, there will be a large desk. On the desk, there are some big computers with the big screens, and all these, you know, your layout for the plant will be displayed. If you have to control any aspects, control temperatures for the steam, pressure of the steam, so this can be simply controlled through the touch screen. Just to give you a good example uh, of the mobile system or TV, we in the mobile, older mobile, you can see the small switches, but now in the uh, recent new type of mobiles, so all these control, even calling, we don't have buttons, we just simply touch the screen, so the operation is completely through the touch screen. Okay, so lot of advancement taking place in the control. So the most of the control operations, just touching the screen with a finger few times to increase or decrease the temperature pressure of the system. So control is system, there is great advancement in the control system. Now we speak about the one very important aspect, that what key parameters what we try to control in the power system. Okay, so these two extremely important parameters which we control in the power system, electrical quantities, are frequency and voltage. So we have to maintain the system frequency, standard nominal frequency 50 hertz, and we have to maintain the voltage in the systems. Voltage in the systems, you will see that the voltage in the power system, it will be different voltages in the different system, in the generation, transmission and distribution. But for example, if you talk about the distribution system, rated voltage is 230 volts. So this voltage we have to maintain within plus minus 5%. So we have to maintain the voltage and frequency within the specified limit. So limit for voltage is the rated voltage can deviate plus minus 5%. Whereas the frequency variation deviation is minimum. So rated frequency is 50 hertz. It can deviate to 51 hertz, can go 49. It can, in extreme case, can go 50 hertz or 48 hertz, but frequency cannot go like 55 hertz. If that happens, then everything will go to the blackout situation. So how we have the control for frequency? Generally, the frequency control in the connected system is through this what you see the wall here. So the fuel input. Okay, frequency control is through this control. And how the control of the voltage will taking place? If you talk about the power plant, the voltage control will be taking place through the generator. The generator we have generally is synchronous generator associated with the exciter system. So this exciter system will control the voltage of the system. Okay, so in the real time, we have to maintain the system frequency and voltage within the limits. So these controls are associated. Frequency is controlled through this valve, controlling the fuel input to the plants, and frequency voltage is controlled through the excitation system. In the real-time system, we have to make the balance for the voltage and frequency. Just to give you example for our human system, if you are not feeling well, we go to the doctor. Doctor will see our body temperature and pressure. Okay, if temperature and pressure are normal, generally we'll see that we are healthy. Okay, but if temperature is abnormal, we say we have fever. Okay, or pressure is abnormal, low pressure, high pressure, it is indication of that our health is not normal. Same way, voltage and frequency, if these are in the nominal, generally we will say that our power system is in the healthy condition. But if these are deviating, then we'll see that this plant is not in the normal operation. Now, just to give you quick overview of the like a thermal power plant. Sorry. So these thermal power plant, people who might have visited, they can understand. But the power plant you see is very complex, very large system, having the hundreds of components systems. Okay, so most of the system what you will see is comprising your mechanical system, in which basically you have the coal handling system, coal uh, handling system, then production of steel in the boiler, then the steam at the proper quality with the proper temperature and pressure, it will bring to the turbines. The turbine can have the different stages called as the high pressure, medium pressure, and low pressure steam. And then with the same shaft, electrical generator will be connected, and through which electricity will be generated. That electricity will be fed into the grid. Okay. Now the steam coming out from the turbine, it will not be wasted, but this steam will have some energy, and it will be reused for the production of steel. Whatever some additional water is required, that of course will be used. But when we have this steam power plant, lot of water is required for its purpose. So obviously this plant, thermal power plant, will be located close to river because significant quantity of water is required. So because of the time, I will not be able to go into very much detail of that. Now here you can see this very interesting uh, slide. It is an example of, for example, a small 30 megawatt power plant, very small megawatt. Generally, you'll see like the individual generator rating will be 100 megawatt, very still small, 100, 200, or 500 megawatt. If there is large power plant, we call it super thermal power plant. The power plant rating can be 2000 megawatt. Okay. Now, you as the engineer might be interested in knowing like how much coal we are burning, how much energy content is there in the coal, and then how much the energy or power we are getting out from the generator, where the power is lost. Okay, so just to give you a very simple example that here you have the power produced in the boiler is 30 megawatt. Okay, then what we are getting out from the generator is 12 megawatt. So the efficiency you see is around 12 divided by 30. So it is how much? Around 40%. Okay, you'll see the efficiency of coal-based power plant is very low. This is one of the major issue. Okay. Now we'd like to see where the rest of the power is wasted. Okay. When we are, you know, uh, producing the steam, then through the chimney exhaust gas, around 10% power will be wasted. Okay. Then, of course, in the turbine, this condenser process, huge amount of power will be wasted. Okay. So these two are the major sources where the significant amount of power will be wasted. Now, the rest will be the power supply. Of course, there are the large number of other components where the power loss will be taking place. This is like very simple way to give you explanation. Now here, this title is that scale model of typical power plant. Now, for example, if you are the engineer, you want to know, like if you have the 2000 megawatt power plant or 1000 megawatt power plant, you want to know, just can estimate how much coal will be required on daily basis, monthly basis, or yearly basis. You have no idea, you want to make an estimate. Okay, so this slide gives you a simple example. It may not be 100% accurate, but it can give you good estimate. How much coal will be required for 30 megawatt plant? Coal required will be 1 kilogram per second. If you have your power plant, say 300 megawatt, so coal requirement will be 10 times increased. So it will be 10 kg per second. Now, if you have to calculate for the daily requirement, then this is per second. So this you multiply by 60 to get in minute. Then you multiply by 60 further to get in the hour. Then you multiply by 24 to get in the daily basis. If you have to calculate monthly basis, you have to multiply it by again by 30. So you can estimate. Now, how much air will be required for burning of coal? Okay, so the amount of air required is 10 times what the coal is required. And how this air will be supplied? So the air will be supplied through this large fan, what we call as the forced draft fan. Okay, the air will be supplied to the plant through the forced draft fan. Now you might be interested in knowing, as I said, where we are installing the power plant. It requires the huge quantity of water, water for the condensation process, cooling of the steam that can be reused. Now, how much quantity would be required? You can see for this small plant, the coal required 1 kg, but the water required for cooling purpose is 360 kg per second. Okay, so you can estimate, you can get an idea that huge quantity of water will be required, which you can supply through nearby river, or in some cases, these plants are some plants are located close to the sea. Seawater can also be used. Now, another point I want to explain, particularly one not from the mechanical background, maybe from the electrical or some other discipline, that steam, the steam temperature is very very high. So temperature is around 550 degrees centigrade, and the pressure is around 16 megapascal. So through this slide, you can get a good estimate if like you are doing the assignment. I don't know whether you have assignment after the course, but it will be good exercise. You want to make an estimate estimate, please try to make say example of like 2000 megawatt. You try to make an estimate that how much coal will be required, how much water will be required for 2000 megawatt power plant. So it's simple calculation, but you can make a very good estimate, and then you can try to match with the real power plant. It will give you some good understanding. Now, people who have not seen the power plant inside, or of course outside, most of you might have seen how this coal-based power plant would look like. So this is a large power plant in Australia. So basically, you can see these are the chimneys where the exhaust gas will be uh, coming out, and then you'll see these long buildings in which your generators, turbines system will be placed. So this slide gives you some in general understanding, particularly the people who are not in the area of electrical or power, that the slide I show you previously, it comprises of like four generators. Each generator rated for 660 megawatt. The generator used have the speed 3000 rpm. The voltage is 23 kilovolts. Frequency is 50 hertz, and of course it is three phase. Then there are four steam turbines. There are four generators. So there are basically four steam turbines, one for each generator. There are four condenser, four boilers. Steam flow per turbine is 560 kg. You can estimate for this type of generator that how much steam would be required, what is the steam temperature, pressure, cooling water requirement. The slide I explained you for 30 megawatt, you can just try to estimate how close values you are getting. Okay, this is another picture showing the this is your condenser part where the condensation of the steam will be taking place. There can be uh, another types of power plants called as the hydroelectric power plants. So depending upon the dam height, the power plants can be classified as high head, medium head, or low head. High head like this big dam about 300-meter high. Medium head can be between 30 to 300 meters. Low head can be obviously below 30 meters. So how you can classify, and through the hydro, how the electricity will be generated. The large hydro will be created through these large dams, and the water will be flowing to this turbine and generator room through these large pipes called as the penstock. And after passing the water through this turbine, it will it just discharge, and it can be used for other purpose like irrigation, etc. So the power produced from the large hydro, it is very neat and clean. We have been producing the power from the large hydro over the large number of years. The power produced is very clean. We call it this renewable power systems. Of course, with the large hydro, we have the issue that ecological imbalance may occur where the large hydro are installed. So during construction purpose, large dams have to be constructed, and there might be issues. Like we can see now near Delhi, you see the Kisan Andolan is going on. So same way, when the new power plant comes for the large hydro, kind of Kisan Andolan, it will start, that it can cause ecological imbalance, and the environmentalists they come, no, you cannot construct the dam here, it will imbalance the ecological system. What will be the height of dam? So there can be big issue. There can be dharnas around that as well. So there are the some issues, but once we have the dam, Uh, Power produced is neat and clean, so this is very nice way of producing the electricity. Then we can have the another type of power plant, we call it nuclear power plant. So here in the nuclear power plant, nuclear material will be used in the reactor, and that basically will produce the steam. Once the steam is produced, then your power production system becomes the same as we have in the coal-based power plant. The only difference we see with respect of coal-based and nuclear is that this part. Rest of the system is more or less same. Okay. Now, in as I talked about the fossil fuel-based power plant, in the fossil fuel-based, we can have coal-based, or we can have oil-based or gas-based power plant. Some of the countries, for example, in Gulf countries, where there is no coal, so the conventional way of supplying the power is through gas-based power plant or oil-based power plant. So in that case, also we can call it like the steam turbine or gas turbine. Basically, the fuel input will not be coal, but it will be like a gas-based power plant. The advantage for gas-based power plant as compared to coal-based power plant is it emits less emissions. The uh, plant operation is very neat and clean. Plant can be very quickly started. So lot of advantages, but the this cost of the gas can be more. Okay. Otherwise, the gas-based power plant is very nice way of producing the electricity. Okay. Now we have given you brief overview of the different types of power plant. Now let us talk log some of the issues what we have with the conventional power plant. But let's talk about the fossil fuel power plant, coal-based power plant. You can see in this slide, of course, in recent time, we are talking about the renewables. The issue is around emissions coming out from the coal-based power plant. So still, when we are talking worldwide about the renewables, still there are a large number of countries, significant power is being produced from the coal-based power plant. If you can see, countries like USA, China, India, uh, Australia, South Africa. So these countries still produce more than 50% power from the coal-based power plant. Even there are so many problems, emissions, uh, but still we do not have options. We cannot add the renewables in few days or month or year. It is not an easy process. So huge power in these countries is being supplied through coal-based power plant, and situation is not going to change in few years. At least next 30 to 50 years, still we have to keep on producing power from the coal-based power plant. So what is the major issue with the coal-based power plant? As we know, the major issue with the coal-based power plant is emission or CO2 production. So some of the countries producing huge emissions are, of course, China, number one, then US, followed by India, Russia, Japan, etc. So this issue of emission is a big issue worldwide. So everyone is looking for alternative. Okay. So if you see this on the right side pie chart, how the electricity is being produced worldwide. So you can see 27% from the coal, 24% from gas, then you can see oil, 34%. I give example of like these Gulf countries. So you can see huge part, 27, 24, 34. It makes you how much? Around 85. So huge power production taking place through the fossil fuel. Okay, lot of emissions coming out. So everyone is looking for the alternatives in terms of renewables, renewables. So this is one of the major issue. But as I mentioned, this through renewables we cannot change the situation in few months, year. It is a long process. So what I mean that still we have to keep on supplying power, producing power from the fossil fuel based power plants. The issues I mentioned are emissions and of course low efficiency. Now let us see the situation of our country, uh, how, how much we are producing from the coal-based power plant. You can see from this pie chart, uh, we are still producing more than 50% power from the coal-based power plant, which is around 200 gigawatt. Then with gas, 25 gigawatt, slight bit from nuclear. We are expanding in the renewables. So renewables here is currently around 37%. In the renewables, of course, we have included the large hydro. Our Indian power system installed capacity is around 370 gigawatt. Okay, so uh, now this slide very interesting. If you see where we are, currently we are here around 2020. So these are the different types of fuels: coal, gas, renewables. This is hydro and nuclear. Okay, so obviously in the past we had producing huge. What I'm giving the picture for the worldwide. So producing huge power from the coal base, then we realized is not good for health, lot of emissions. So power production from the coal is coming down. Okay, then renewables. So we around 2000 we started producing power from renewables. We are increasing share, but still we are sitting around 10%. Okay, so we from the renewables by say next 20 years we may come renewable some respectable share worldwide, say around 30%. Okay, so basic issue here is that we want to reduce the share from the fossil fuel power plants, increase the share from the renewables so that emissions can be reduced. Okay, so this we cannot do in a few months or year, because the power industry it requires huge investment. If you have to generate 1 megawatt, it requires typically 5 crores. Transmit again another 5 crores. Distribute another 5 crores. So just to generate, transmit, and distribute 1 megawatt, it will require typically 15 crores of rupees. Okay, so power sector requires the huge investment. So changing something over a day is beyond the control of government, and it is not a you know instant process. Okay, we are talking worldwide, and as I show you in the previous slide, the situation is not like the India or one country. Situation is more or less same in uh, underdeveloped, developing, or developed country. It can be slightly different, but it's not the totally different situation. Okay. The another major issue you see for the fossil fuel or coal-based power plant.
Professor Bansal, can we conclude now?
Yes, it's fine. Then we will continue uh, in the coming slides. We have, I think, around 13 minutes more, but we want to take some questions. Eh?
Yes, this is the question time now.
Okay, maybe just give me 3 minutes more.
Okay.
Okay, so here, uh, improving the efficiency of fossil fuel based power plants. So generally you can see in this slide, efficiency of the coal based power plant can typically vary from 30% can go to 43%. Even variation of like 1% efficiency, it can have significant impact like the country like our Indian system where we have this 200 gigawatts. So even if we can increase efficiency by 1%, it will be a big relief, big relief. So how we increase the efficiency of coal-based power plant? This is one of the another challenge. Okay. So efficiency of the coal-based power plant, how we can increase using the combined cycle power plant or using the supercritical power plants. So these are some of the things we can do. But even we have very high-tech power plant, but that plant is not operated nicely, even the efficiency will drop. So when we have very high-tech power plant, then how we operate is one of the important aspects. So here, one of the problem in the power plant is what we call as the slagging and fouling problem. During the production of steam process, we can see that a layer is deposited on the water walls called as the slagging layer. You can see in this picture that will badly affect the flow of heat. If there is more slagging, then loss of heat will be taking place. Now, how we can minimize this layer through this pressurized steam? Sometimes this layer increases, we may need to uh, shut down the plant for the cleaning purpose. So this will again badly affect. Now, this research was conducted one of my PhD student that how we can minimize this slagging and fouling and how we can improve the efficiency of coal-based power plant. The production of steam is really very complex process. So how we can minimize the emissions and improve the efficiency. So if you have some modern high-tech plants, so if we can integrate real-time simulation with the online learning technology to improve the boiler combustion process. This will reduce the emission and it will improve the efficiency. Using the high-tech cloud computing, high performance computing, uh, to build up a platform in which the boilers can learn in the real time so that boilers can be tuned, efficiency can be improved, pollution can be minimized. So this research was published in this book, how we can improve the efficiency of the coal-based power plant, how we can minimize the emission. So this source code are freely available. This research can not only be applied in the coal-based power plant, but wherever there are industries using the boiler process, this can be applied. So I'll just stop for the questions and answers, and I am happy to take the questions. Dr. Bhardwaj, your voice is not coming.
Sir, one question from Sneha Verma. She is asking what is importance of reactive power in power system?
Yeah, is very good, very interesting question. In fact, I did my PhD on the reactive power. You
Reactive.
know,
Yes,
of
correct.
course, you can see the difference between the real power and the real quantity and the imaginary quantity. Real reactive power we call as the imaginary quantity. Okay, so this appears to be the imaginary but still very important. Uh, so here the reactive power is required to operate the power system, operate the electrical machine. If you see in the electric machines, the magnetic field is required to be created. Okay, so it is basically through the reactive power. Okay, so uh, reactive power, the importance of the reactive power in the electrical power system is that the reactive power balance between the generation and demand will maintain the voltage level. If we have more generation of reactive power, consumption is less, then voltage will shoot up. If there is more consumption of reactive power in the inductive loads, so voltage will go down. That's why in the industry, we will pressurize the industry that you place the capacitor bank to improve the power factor. Even the guy power factor will
Correct.
be basically depend upon reactive power. So these like there is share of 50% for the real power and reactive power. So reactive power equally important. In recent time, there is more importance given to the reactive power, that we are in the electricity market environment, like the bidding pricing. You know, in the power system network, there is sudden requirement of the reactive power. So there are the dedicated power plants through the condenser power plant, which can supply the reactive power to maintain the voltage in the system.
Correct. And another question from one person: what are the difficulties we are facing switching to renewable sources?
Yeah, so it's a good question. So we will of course talk more about the renewables. We'll take more, but just to give you, as I explained you, uh, I'm happy to see the maybe participant Dr. Narottam Das from CQ University, Australia. My greetings to Dr. Narottam and
Das, welcome you. Welcome you.
yes. So I know him, Dr. Narottam, and maybe if I see participants, many participants I can see. So basically renewables and the situation, as I mentioned, story is same worldwide. Uh, the technology, particularly when we talk about the wind and photovoltaic system, we have the technology. There is no issue of technology, but you know, placing the capacity, like say here in the power system for a country like the our Indian system, we are talking about the capacity in terms of gigawatts. I think everyone knows this system: watt, kilowatt, megawatt, and gigawatt, right? So here in the renewables, when we are in like the small our residential system, we are placing a small systems in terms of like few kilowatt. So adding the capacity in terms of gigawatt is a really challenging task. So we are placing worldwide renewables, but it requires the huge investment. It requires the proper infrastructure for the transmission line as well, because renewables might be in some remote areas, there may not be available transmission network. So there, and then other issue with the renewables is that, of course, they are renewables, but they are intermittent in nature. So it becomes more challenging task with the renewables. We'll speak more when we talk about the renewables.
In the continuation of the question, why the efficiency curve has some uh, difference, because with time and technology, efficiency should only increase.
Efficiency of maybe coal-based power plant, or which efficiency?
This
Which
question
one?
is, yes, Abhi Singh, you ask again and clarify. Mr. Abhi Singh,
Maybe if student, the participants can speak as well if they wish.
they can speak also.
Yeah, participants, it would be good rather than writing in the chat box, welcome to talk.
They have written this question in the question answer box. So why the efficiency curve has two participants raised the hands? Who raised the hands? I can give you. Yes,
I
Sunil
think
Goyal asked.
that person can ask directly is better.
Yes, yes.
So what is the
So it
query?
will be good. It will be good to
Abhi Singh,
interact.
you ask the question.
Hello, yes, sir.
Abhi Singh, you ask the question directly.
Hello, sir. Am I audible?
Yes, yes,
Yes.
you are audible. You can increase
Sir.
slight bit your volume.
Yes, sir. In your slide, I saw a curve of coal-based plants. I saw that with time there was some dips. So with time, with technology, they should only increase. Why was there some?
Yeah, certainly it
down
might be a good question. Like, you know, in a country like, you know, there can be, you know, the power plants procured from the overseas. Okay, so from where these power plants are procured, it is like very costly system from where the, you know, power plants are procured in a country, and which type of power plants. So sometime you procured more power plants from, say, China. If the efficiency is low, overall efficiency will come down. You brought the high tech power plant from Germany, its overall efficiency will start increasing. So basically, and you have to see in a country how much investment you are making, which type of power plants you are buying. So this slight bit, you know, increase or decrease can come. But if you see overall, some countries like our Indian system, efficiency can be around 30%. But in some developed countries like Germany or some other countries, efficiency can be 40%. So in coal-based power plant, efficiency is extremely important. If you can increase like 1%, it can have big increase.
Another question from Dr. Ramesh Chaurasia. How we decide the size of transformer on the basis of load?
Yeah, so basically, it's a good question that how we will decide the size of any electrical system based on the load, whether it is cable or transformer. Basically, we will calculate the, you know, from the load, we'll calculate the current, and from the current, then of course we will consider suitable safety factor, and considering some more technical parameter will make the decide the size of the transformer. Then of course, if we have the transformer like in the distribution system, we may consider whether, you know, we have like one transformer or we have two transformer, three transformer, just backup of the transformer as well. So we give the consideration to the several points.
Correct. And next, Professor Sunil Goyal is from our institution, will ask you some question. Professor Sunil Goyal. Professor Goyal, are you listening me? Goyal sir, phone karo. Goyal sir, phone karo. Professor Sunil Goyal has raised the hands before few minutes. Now we are going to call him, so they will ask you the question.
I think so, not responding.
I think they are not responding. Technical problem maybe.
How are you, Dr. Narottam?
Good, Professor Bansal. We have good memories that I told to the Professor Bhardas also. So our good network.
I believe we met in Tasmania, or where we met?
Tasmania, Bali, we went for lunch together, and also UQ.
Yes,
so
yes.
many times.
Very nice to see you.
Yeah, very nice.
Hope you are keeping well.
Yeah, hope you are also okay.
Yes, we are keeping well.
COVID issue is very difficult all
COVID
over the
world. Is worldwide.
Melbourne was a special case. It's very difficult.
You see, you know, how the technology is changing. We have, you know, smart system, smart grid. Unfortunately, last year we come up with the COVID. So any person want to publish, so add COVID in the paper, so there will be good chances of publication.
Yeah, that's right.
So now people are finding the way how electric system can
Yeah, that's right. That's why this time also OPEC was online, as we did the UQ, OPEC and others. So all Tasmania, this time also Tasmania, it was online OPEC.
Okay, good. So you are currently in the CQU.
Yes.
Okay.
So located in?
This one is in Melbourne. Before I was at Cartin, and then Cartin to USQ in Tumba.
Okay.
And then from there to CQ. So I talked to Professor Tapon about you, and he said you left this. So far I know. And also Akhtar Kalam mentioned about you.
Yes.
Professor Akhtar Kalam also.
So hopefully we look forward to stay, and you are in the Melbourne.
Yeah, now in Melbourne, yes.
Okay, so hopefully we'll see you maybe sometime.
Yeah.
Or if you visit maybe Dubai or this, so we are welcome to.
Yeah, we'll keep in touch and then we'll communicate. So very good memory was in Bali. So that was long. Yeah.
So thank you very much, Professor Bansal, today.
Dr. Bhardwaj, I'm very delighted that you are doing this organization in excellent manner. We saw this, with COVID only online. You have offline plus online hybrid system, and you have organized it, really excellent matter. I was not expecting that you will have some delegates from the Australia as well, whom I can recognize. So you are really doing great work.
Actually, I have contacted Siemens regarding that for the offline purpose.
Yes.
They have given me a trained person to give them on-hand training on the machines.
Okay, very good, excellent.
So one assistant manager is from there in our organization today. So they will give the proper guidance on hand training to the participants.
In fact, big industry, big institution will fail in the COVID situation. Everyone will say, okay, we'll organize offline.
Yes.
But when it comes to actual implementation, everyone raise the hand. No, we cannot do that.
But we are able to do this.
And this is something extraordinary,
Yeah.
Everywhere you see, like here we will have they say, okay, we'll conduct the online exam, and when date will start coming closer, then say, oh, it is difficult.
It is too
so we just do online.
Yes,
no,
but it is happening last year.
Just give me 1 minute to talk.
Yes, please,
I know
please.
Professor Bansal very well. As like the online system, if you think about in Australia, big universities, they don't know well. For example, Monash. I was at Monash in 2004. Now ADR, Malin is my very good friend. He said, we don't know how to do online, but in smaller university, we know. And then they said, we are doing 20 minutes video. No, for these small universities, especially CQ, USQ, even Carton and others, they are doing 2 hours, 3 hours video, like a whole stream. Thank you. I think this is good chance and good to learn online way how we can participate in case if anywhere in the world, if you don't get visa to go there, at least you can do the hybrid system online. There would not be any issue. Like this time, IEEE PSGM, it was online.
Yeah. In fact, in this COVID, the only good part it will be coming out is that this, in education system that you can avoid this unnecessary travel. You can minimize the cost, optimize your system, optimize your resources, and even learning can be sometime better than what we have the online. Everything is recorded. The resources available are more in the permanent nature.
That's right. Like CQ University, everything's recording. Even I have a student meeting, whatever the conversation today.
Certainly.
And because not this one, because they are recording and then I'll get the file and send to my PhD student, master's student, whatever conversation we have, don't forget, at least you can remember all recorded.
No, it's good. Even it helps in the learning process as well.
Okay, Professor Bansal, thank you very much for the
Okay,
session.
so it has been pleasure, and then I look forward to see you tomorrow. Tomorrow we have two lectures. So briefly, I talk on the diesel generator, then mostly talk on the photovoltaic system. Then diesel generator, I speak on the last day as well.
Okay, thank you very much.
Thank you very much. All the best. All the best for all the participants. And maybe I will share my slide maybe all together in just like one combined maybe tomorrow, and you can share with the participants as well.
All right. So thank you very much. So next is
We are going to be close the session. Wait for a few seconds.
Professor. What does? Can I share my slides?
Welcome, Narottam Das sir, once again. Let us start next session.
Okay. So can I share my slides?
Yes, sir. Yes, sir.
Thank you. I will share now.
So your slide is visible. You can start.
Okay. All right. Just a little bit going back from here. We'll start a little bit. Anyway, good afternoon, everyone. As I started my presentation yesterday, we will continue from that one. Just we talked about modern digital substation. We stopped a little bit after, but a little bit back from there. This is the expected modern digital substation that we hope, and what sort of things we have to consider. that we discuss the communication substation communications that we need here, already discussed yesterday. Provide effective substation monitoring, local, remote and control protection, primary and equipment monitoring, and all other functions, establishing multifunctional IDs and network communication technologies, sharing real-time data between all substation devices, flexible and its scope, control and expandability. Because if we set off right now, after 10 years, what will happen? That's why we need also the expandability capability that is possible. And then we have to replace the conventional cities with digital cities and VTs. So that is on already discussed yesterday. This one I got from my student. So he worked at Western Power, that explained already. And this one also from Western Power as Alstom product for merging unit. So this criteria, as discussed, we have to follow this one. Okay. Then instrument transformer, also discussed yesterday, just a little bit recapping what we have, and then typical design for cities. So at the end, we'll get digital substation like this. So that is the expectation. And there was a question how we can get less weight. So we are coming to that on. Of course, we will reduce the area and for secure system, as well as the less weight, less labor and so on. But initially there is difficulties that one need to overcome. So this on also switchgear equipment, because we are using fiber optic technology that is worldwide everywhere currently using. I visited this Western Power lab many times. I have seen that on. They are mostly using fiber optic technology. And we stopped here, weight reduction in GIS, and then what was the cause here? Digital options, digital current and voltage transformer is there. And if we think about the space, so we can reduce the space saving, because yesterday I already shown that need wider space, all manual work, and then bigger equipments, coppers, wires, and others, and lab areas need to maintain. And then we can remove that on VTs. Definitely, we can reduce the size, weight, and other cable issues, even for long-term plan. So it is useful for future generation. So I think it need, because our equipment is compact, it will definitely reduce the weight and space also, and labor cost also. And other safety features, digital one is more better than as conventional we have. And then we are coming to this protocol in general. What sort of protocols, why we are going to use this, and what are the issues? A protocol basically is a set of rules that must be obeyed for orderly communication between two or more parties, because we have to communicate very appropriately, and that on is the communication 2, 3, 4, whatever the IDs we have, we can communicate. Communication between data processing system from different manufacturers also there, and then often when particularly difficult due to the fact of that has been separate development of data processing, but different vendors, different manufacturers, there is a compatibility because we are following the ISO, and the data communication techniques often resulting in complex and expensive interfaces, of course. And then this ISO, or International Standard Organization, who is commonly known as Open System Interconnection, OSI or ISO, and then the communication space has been divided into 7 basic layers as shown in next slide. So in this case, just mentioned, this is the figure, this is actually in the text, and then this layer, physical layer model, that is OSI, we are going to use. So the OSI reference model said if we consider from here physical layer, data link layer, network layer, and then so up to the application layer, this is the continuation. And then from here also we can see the physical layer, how it works. And then these layers define how data flow from one end to a communication network and other end, and vice versa. That means on to, like if you say 1 to 2, 2 to 1, how it would be. And this one, of course, going to through this media, and the two devices may can only communicate. Each layer is the same model. At the sending device matches with each layer in the model at the receiving device. That means need to be similar model. So that sort of issue, but different vendors, and there is adaptability, and it is possible to use. And then in this case, the user can quite often make choice in any given layer. They can find out, and this choice can be made, implement a protocol in term physical, and then the rules designed by protocol is the profile are designed to organize the open issue for the considering the following areas. These are farming, error control, sequence control, transparency, line control, timeout control, and startup control also. And we are considering this. Then any question from anyone?
Yes.
Any question?
Any question from student side?
No. I thought maybe some sound. That's why I thought anyone asking anything. That's why.
No, nothing.
If not, then I will continue and then discuss at the end.
You continue.
All right. Okay. Thank you. There are literally thousands of combinations of protocol agreement that can be created with the large domain of existing pieces. And these are considered the following on, and the protocols have found widespread in substation environment. There is a Modbus, DMP, that is the distributed network protocol, ICs, and UCA. So if we consider the Modbus is a popular master-slave protocol with industrial users, and then become very much popular in substations, and then it is very simple, read and write, and commands addressed to inside an IED, and then distributed network protocol, increasingly the popular master-slave because that is in North America, and DMP can run over multiple media such as RS-232 and RS-485, and can issue multiple types, read-write message to an IED. And then IC, it was 8705, and then this is considered the European partner to DMP. And then different itself DMP with slightly different message structure, the availability to access object information of the IED, as also mentioned yesterday about the user communication architecture. That one is designed to satisfy the possible requirement in substation equipment. So we are coming to that, and then DMP say there are DMP category 1 and category 2. That's why DMP 1, DMP 2 can be used construct parallel structure for simulating large scale neural network models. And this in this relationship, they said the DMP was implemented in 1991, and the DMP2 was implemented with the VLSI chips, single multi-processor having 4 DMPs, and then DMP2 has the performance of 50 MCPS, that is million connections per second, 50 million. That is a very high number at the 50 megahertz, and the microprocessor and having 2D message structure 12024 DMP2 accomplished maximum 14 giga connections per second. So this is a very high number. So far, the structure of DMP, a processing element, the DMP is an 8-bit microprocessor device, and with instructions and data path for client neural computation, weighted sum, and non-linear function, etc. Something mathematical. It is not linear. Most all are non-linear. So DMP1 consists 3 block units. These are arithmetic on unit, a control unit, and communication unit. So far, and DMP2 has 16-bit microprocessor. Difference is 8-bit microprocessor for DMP1, DMP2 16-bit microprocessor, and its architecture is similar to DMP1, exclusive for parallel arithmetic constructs and 2 pipeline functions. That's why DMP consists with arithmetic unit and control unit. So the difference is here, size and speed. It is necessary to compare the DMP1 and DMP2. What are the difference between them? So this table 3.1 shows that one can obtain the results and the function and the parallel and the other one is parallel. The cost performance, if we say, comparing with the processor, DMP2 are cost efficient for neural network emulation. So this is the comparison table. So DMP2 is cost effective one, that one is useful. So in this case, for implementation and performance, we make the DMP2 is a processing element for large scale parallel neurocomputer and fabricate 4 DMP2 into one chip to increase the density of system integration. And then also it is using 0.84 micron CMOS, that is a complementary MOS coming from electronics. I think it is well known to everyone. And the target of 50 megahertz clock rate. Then the chip features 299 pins and the power dissipation of 2 watt at 50 megahertz. The silicon size measures 11.5 times 11.5 millimeter square to integrate about 60,000 gates and excluding on-chip memory of DMP2. So that's why DMP has peak performance around 50 million connections per second. That one already mentioned before. So far, then after that, coming to DMP3, the DMP3 is a set of communication protocol and it plays an important role in Scada. Scada is well known to everyone, the supervisory control and data acquisition system, where it is used for communications between system component, and the protocol was specifically developed for facilitating communication between data acquisition and control devices. So that one is for DMP3, and then it is an open, intelligent, robust, and efficient modern SCADA protocol, and what it can do, what are the functions that is important. So this requires respond with multiple data types in a single message. That is one message, they can send that on. Segment message into multiple frames to ensure excellent error detection, include only change data in response message, and then assign priorities to data items, which one go first, and then data request item periodically based on the response without request answers, and then support time synchronization and standard time format, and allow multiple master and peer-to-peer operations, the peer-to-peer communications, and then allow user definable objects, including file transfer. And then this DMP3 provides multiplexing, data fragmentation, and more. So DMP3 is a layer 2 protocol, and this means it provides for multiplexing, data fragmentation, error checking, link control, prioritization, provides layer 2 addressing service for user data, and DMP3 enables the various in-process automation system to communicate. That's why DMP3 is widely used in electrical and water industries by utility companies, power and water companies also using. It also possible that DMP3 to be utilized in other areas, though it is not a common, but it is possible to use in other places. And then we are coming to Scada system, and which is DMP3. Scada system uses DMP3 protocol for communication between various systems components, and this DMP3 provides for communication between the Scada system master and the system RTU and IEDs. So, and then this DMP3 was developed to meet the need for standard communication protocol, but it allows the communication between Scada system component developed by different vendors and using IC 60870 that we told as a base, and DMP3 was created as an open protocol for this situation. And then this protocol was available for intermediate implementation with Scada network, and then create a specification laid out by North American organization. But we came back a little bit before the distributed network protocol, but linking to, we want to link the IC 61850. We are coming to there soon. And that purpose, how the background we have to know, otherwise, and then when you are doing the job, then it will be difficult. So provides communications reliability for utilities. That is also important. So then we are merging together. This DMP3 ensures the communication within harsh environment of electrical and water utilities. Is protocol is available being distorted by EMI, legacy system component, poor transmission due to DMP3's specifically designed communication format. Although the protocol was created with reliability in mind, and DMP3 is not secured, an important consideration during Scada's planning, and one can protect important DMP3 communication and Scada system with a network alarm monitoring system. That is also very important. And the most advanced alarm masters can monitor the DMP3 protocol and enabling on receiver their critical DMP3 and other protocol alarming is in a single convenient browser window, sending on alarm notification via email or page, and then alarm master will inform instantly if there is a problem within the operation. So that features are there. And then we want to say something physical talk where they are using. As Professor Bansal also mentioned, different countries, they are using different, but little bit different. Of course, I agree with that, but it is very close. It is possible. Like I'm giving you the example, an Australian practice. In our university, we are teaching Australian engineering practice, because I think India also using a little bit Indian perspective, but the system is pretty similar. So SP Ausnet, as I mentioned yesterday, SP Ausnet is Singapore, Australia power network. It is based in Melbourne. And then concern between this one has connecting between IDs and RTUs. So the most common connection requires RS485 and RS422. That is, RS422 is a multi-drop with DMP protocol, and each ID has unique DMP3 address. So far, master sends messages with destination address, and then all IDs on the bus receive the message, but only matching the address ID responses only. A specific address match that on.
Professor, one question from our student.
Yes.
What is the role of IED in smart substation?
Okay, we'll discuss that on, because coming to that point, so can I discuss now or can I discuss later on at the end?
Another question from the students.
Yes.
What is RTU?
RTU?
Yeah.
I just explained here. I think, yes, remote terminal units, ID, intelligent electronic devices.
Right.
Because the system is there, and then ID's function, sending the message, collecting message, and the disperse. That one we'll discuss in details later on when we see the connection.
Correct. Okay, carry on, please.
Okay. Thank you, Professor. So now, if anyone, any question, feel free to ask, no problem at all. I will not forget because then I can go back a little bit and then try to recover. Any query, most welcome, no problem. Okay, so as we are here, and then all IDs on the bus service receive the messages, but only matching the address IDs. Like mobile phone you have, you will receive only the designated messages, not everyone's message. So designated message, that one will collect. We'll discuss more details. And then I am talking about this perspective, as said, Australian perspective, Professor. So then it is easy, otherwise it will be difficult. So SPOSnet, the handful analog circuits used SCADA communications between RTU and the control center. We discussed about the control center yesterday. That is the message collecting from different places, any issue, any data, any alarm, computer will display that one. So far, the rest is RS-232 circuit, use digital 64 kilobits per second, channel back to control center. That was there as SPOSnet digital network, and then switch is used to provide all communication requirements, protection, control, and SCADA, and then also Ethernet that will separate gigabit network where is possible, high and provide corporate engineering access to IDs and terminal and zone substation. Future development will be operational IP network to provide SCADA on IP, because these are the application realistic in SPOSnet in Melbourne. So that's why we are talking about this. But I think India or any other country is pretty similar. This is a standard protocol, that is OSI as mentioned. So now we want to come back. We talk something, many backgrounds. Now we are talking about the two standard emerged, UCA and 61850, how it could be, what are the background, what we need inside. That's why we talk something background. If we don't talk about the background, then it is difficult to understand. That's why we try to discuss about that, because these two standards, because 1994, initially it was started in April, the user communication architecture, and then the plan, and that one also linked with IEEE on, and then this on 1994, later on it came to 1996, IC, and then TC57, IC, International Electrotechnical Commission's body, and the number is there. That is the protocol that I explained at the first slide. Hope that one is memorable to everyone. But those are working in this, they know, even university side also many knows. But if any question, feel free to ask. And then technical committee 57, that one also there. They think about the IC 61850 protocol, that is standard profile and global standard. Everyone can use, any country, but some different vendors, it would be a little bit different, like ABB and other on, that one we will discuss today. Then we try to merge these two, UCA 2.0 and IC 61850. So this is the on and this is another on. Then we merge it, mold it, join it, addition, combination. Then what we can do? Then we can see the UCA is a smaller area or smaller combination, but IC 61850 is wider. That means if we consider IC 61850, that one can accept the UCA 2.0, then there should not be any issue. But it took a longer time. So they have the issue 1994 and then 1996. Then they tried this protocol 1997 to 2003. It's about 6 years. Industry, academia, and many user groups. Then they came to the conclusion this format. So if we consider IC 61850, we will not miss out the previous one, because as I said yesterday, we are already using that one. We cannot say this is old, put it in a rubbish bin. Nobody will not do, industry will not do. But this IC 61850 will cover that one, so we can proceed for this one. Okay, Professor, any question?
No, nothing.
Okay, all right, thank you. Just I talk a little bit background long time, and then we'll proceed now. So if we learn IC 61850, then we can cover this, so we can proceed now. Then,
Professor,
as I say, yes.
One question from our faculty members. Why the name 61850?
Okay. Okay, that on a specific. Yes, that is a very good question. Okay, there are a specific number of this on. Can we discuss that on later on?
Yes, we can discuss later.
Okay, so and functional mapping, UCA 2 into IC 61850, as we have seen the graphical on, and then we are going to merging how it works. And then yesterday we also talked about goose, something but not in details. So far, the device here UCA 2 and 61850, and then there is X, Y. It could be X, Y, there are X and Y, different numbers. So that a number like as a corollary, as I mentioned yesterday. So these generic object models for substation and feeder equipment, this is GOMSFE, this is the abbreviation from here. And then this one is the device models. And this one linking with, if you see the UCA2 component matching with this IC 61850, and there are different parts, 10 parts, I will discuss that on. This one is matching with part 7.4, okay? And then common class definition, that one also coming with UCA2, and then common data class and attributes 7, level 7, we're coming about the level soon, and then standard data types and common components with 7, and then common application and service model, so that on link with IC standards level 7 and level 8. Level 7 abstract communication service interface, that is ASCII, SCSI we know, and then mapping to MMS and lower layers. So this is the link between UCA 2 and IC 61850. So far we are progressing for the next, and then this is the standard profile for IC 61850, and this one is, if we see here, these sample values are here, and then as said, GOOS, that is generic object oriented substation events, and then time synchronization, and then core SCSI service, generic substation event, GSSE, and this is the standard protocol, and this is, we can say, the IC 61850 protocol as the profile, and that one can merge, and then two system can be the combiner. It is useful. Okay, and then as said, this standard, there are 10 parts. So part 1 is the basic principle, and then part 2 is the glossary, and then 3 the general requirements, and 4 system and project management, communication requirement, substation automation system configuration, and basic communication structure. This is 7, and then 8 is here mapping to MMS and Ethernet, and then 9 is here sample measured values mapping to Ethernet, and then okay, then we are coming to the 10, that is a comments conformance of testing confirmation, so that is 10. Okay, and then we are coming to what? Then we are going, what sort of information came for as an example about the interoperability. That on demonstrated in Vancouver, that is in 2001, as per the history, and that time industry also participated. You can see that time Omicron, and then Siemens, ABB, they also participated, because we need to industry compatible and they can use it. Different vendors, different types of configuration, but need to match globally as a standard. So they say 0 is the configuration, 1 simulated fault, 2 trip connected, and then new position, recloser command, and new position. So ABB is switch here the simulation, and their system connected with the Siemens as well as Siemens relay and ABB relay. Also test equipment Omicron. I think we have also Omicron. I have also good correspondence with them, because they are providing equipment support for test, IC 61850, CMC, and other types of also. So in this case, this I mentioned the GOOS message sync trip, GOOS message is position, and GOOS message is position. Okay, all right. And then this on took a longer time, because as I said, 1997 and then 2000 on, they discussed about 4 years and then finally demonstrated in 2000 on. Okay, just then if we say the concept of this on, the GOOS concept is suitable for transmit trip signals over a serial communications, and the use of configuration language to configure the GOOS message facilitates interoperability between devices from multiple vendors. So if different vendors, or it is also possible. So with the demonstration at the UCA user group meeting, that one just said now, and then an important milestone towards the global standard was reached, because if different companies, their product is different type, and then cannot use, that's why I need global standard, one company to another company, and they need to be adaptable, acceptable ranges for application. That one was decided, and then the primary parts of these 6 is also important. This is substation configuration language. We need the language configuration. That's why also need computer engineer also, programmer there, abstract communication service that I said, ACSI, and base types and common data class, CDSIM, and logical nodes. Also, for this on is important because a specific communication services mapping and MMS and Ethernet. And then sample values over Ethernet also required. And then, as said, conformance of the testing, confirming, so that one also important. So we need this. Then we want to come to the structure of the substation. And substation, as said, what is the function of IDs? Someone asked. So here you have the substation bus and IDs connected here, and process bus, Ethernet, and merging unit. So far, the intelligent electronic devices, messages are collecting and passing, and then remote access and network is here. Okay. And then if we go for, as said, I did not discuss about GOOS yesterday. As I said, this GOOS is important because generic object-oriented substation event, that is important, and there is a mechanism fast transmission of substation events. If any fault, anything occurred, that one should be transferred, okay? Such as any command, any alarm, any indication, or any message, any issue can send and transmit. So far, single message sent by an ID. As I said, ID can send message and can be received. ID and used by several receivers. So far, this message can be sent and can receive. Okay? And then GOOS takes advantages of powerful Ethernet and supports real-time behavior. So you will get the message instantly. So this one is also useful. And then it is used for tripping of switchyard, then starting of disturbance recorded, and providing position information. Indication of interlocking, if there is any issue, that one can be find out. Okay, and then as said that this device is a multi-device communication, local or wide area network, it is possible. Okay, and then bridgeable but non-routable user-defined data sets sent in an Ethernet multicast messages and message sent on change of state as well as periodically to enable detection or device failure. And data will set up in a file, then even anytime they can read and then find the issues, what events happening over there. Also affecting the reliability, and this reliability affected through message repeat, and then GOOS headers said multicast address, and then name, they will write the name, what are the issues over there, time until next GOOS message is coming, so etc. This one can do function. And user-defined data set, status information, and analog values, data quality and time, recording also there. So far, if we see the example, because on device, there is a sender, publish information only on subscriber devices, and receiving it, the reaction of each receiver depends on its configuration and the functionality of this as a GOOS principle. Say as example, here we can say a GOOS sender sending the device number X, the message. So here is the message. And then this is the pathway of Ethernet, and then receiving Y message, and then here also receive the device Z. So far, sender is X and the receiver device Y and Z component. Okay, so for yes, this one also, as I got it from Alstom. So they provided, actually, I said my student work in Western Power and then got from them. So far, so what is happening, the functionality, and then if we go for test configuration of phase 1, then we can say the 100 megabit per second redundant switchyard Ethernet ring is here. Yesterday we discussed about different types of configuration, star, ring. Also there is hybrid is possible. So far, in this case, the ring network, and then the goose message is here. This is the one, and then this one said Kema Uni is CA. IC 618 goose simulator is here. This is the brand name. And then this is the network analyzer is here to get, and then this is another also IC 61850 analyzer. So this is also from Alstom, and this one is just simulator network analyzer. So it is possible to get the data from here. Then substation configuration language, that is usually noted as SCL. So this on said that the SCL is the basis for success of plug and play. So in this case, the SCL provides a common object and configuration description. So if you see here, this file distributed and agreed by AS via email. So this one is also providing information via email and messaging. So results of phase 1 is here. I think it is possible. Yeah, this is test on plug and play. Okay, so far. Then the tripping via goose message, because this one is the goose message with the commands for circuit breaker, and tripping and disturbance recorded starting configuration. Sender is X and receiver is Z. So in this case, the fault simulator is here, and then goose message sender as said before, and then goose how they are sending the message, and then this is the Ethernet, the path, and then Y does not react. In this case, the receiver Y does not react, but reacts only this goose receiver Z, because circuit breaker is off here. So far, how it works, that one is mentioning here, and then in this case, goose message with commands for circuit breaker tripping and disturbance recorded starting, and sender is Y and receiver is Z. From Y to Z, if we compare here X to Z, as I said, sender is X and receiver is Z. So here sender and receiving Z. But what changes are here? Someone say it is similar. No, it is not similar. Here the sender, but this X is not sending, and then in this case sender is Y, this is the device, and receiver is Z. So far the difference is there. I think it is understandable that it is different. So fault is here, then sending to Z, and the circuit breaker is off here. I think this is the test result, and then Then we are going for the background of traffic. As said, we got some information about the results, performance test, background traffic, and then this is the simulator that we have, and then 100 megabit per second redundant switchgear Ethernet tripping, and then sender device, receiver device, this is receiver device Z, this is Y and this is Z. So far, heavy bus load is here and produce 10, 50, 150, 300 goose messages within 50 milliseconds. That means very short time, there are many messages that one can send. So far, and then measured, and then, okay, so this one is circuit breaker off, and measured time fault is here, and this one circuit breaker is off. So sender, receiver, Y and receiver Z. Okay, and then we can, so far, yes. And now we are going for another set and then see the difference, because this is the simulator here, then this one simulator, and then heavy device on load, because bus load, and this is heavy device load. Device is here. So far, in this case, also produce so many goose messages within 50 milliseconds. And then heavy load is here, and then this is the fault, and then device received Y, this is device, and goose received device in Z. If we compare here, and then we can see this is the heavy device load, and circuit breakers are off here. And then finally, what we got optimized on, if you see that this on performance test, average, this is 25, and optimize nearly, how much? It is nearly 7. So transmission time depend on today's software implementation. Software is important. That's why you need computer and programming engineering. And then bus load or device load had no major effect. So that one is important. And this we can see the transmission difference. Optimized on is this. And then if we see the results, then we can compare that interoperability test. Positive test is 9. Correct message transmission between configured sender and receiver. Then negative test, selectivity and security, message ignored by non-configured receiver, this is 9. And degraded test, quality and test mode, reaction to quality or test messages in all services, that is 10. And the performance and load test, response time measured with different background loads, that is 11. So far, yes, we can get the combined results here. Combined, we can see variance from the rejected response, and then dismissed test cases was used to improve the IC608 specification and implementation. That one is required. Yes, I think mostly there, and then we need to compare the IC and IEEE standard involved. So that one, I think better to discuss some questions, and then if no question, then we can proceed a little bit. Yes, Professor Pardos, so we can little bit discuss, not only talking, if there is something to know.
Yes, Professor, as we have already discussed, Rajiv Ranjan has asked why the name 61850. You please clear that question to particular person.
All right, 61850. Yeah. I remember that one, but Yeah, 61 there is a specific name, 8 is our name, and then 5 and 0. So can I respond to that on later on, maybe tomorrow? So I remember the name, but the name is not. I have seen, even I went to the industry and written there, but that on I will email to you, as well as I will explain to next presentation at the beginning.
No problem, no problem. You can do.
Sorry,
But
well, that one I have seen. I went to industry, even Western Power and others. This is the 61. This is this one, that a specific name. I will explain later on. So
actually,
otherwise, I cannot give any
misinformation.
information.
Which was formed, as per my knowledge, there was a committee which was formed.
Yes, committee, that's right.
The numbers.
Yes,
and
yes.
Each specific number having the meaning.
Yes, yes, that's right.
So that is clarification is required. So you can give in the next.
Yes, definitely.
You can give the answer for that. No problem.
Yes, definitely I will give the answer. Even any question later on, anyone ask, not today, tomorrow, at the final day also we can discuss.
Okay.
As they have the query.
So Rajiv Ranjan is agree for the answer in the next meeting.
Yeah. Okay, no problem. I will send you email, as well as I will answer and explain to them, and you can forward that on to that person.
So if anybody want to ask any question, then that can raise the hands.
Yeah. No problem at all.
And maybe write on the chat.
Yes. Feel free to ask, and then we'll try to answer that on, and then that is called knowledge sharing. Whatever I have in my basket, share with you, and then I can get something from you also.
Okay. So, Professor,
that's why we need meeting, conference, workshop, and so on. Yes, right? Yes.
So you can continue the topic, Professor Das, here.
Okay, so we can little bit continue.
Yes, you can continue.
All right. So far, we little bit link about the IC and IEEE. So IEEE, those are electrical engineer, even energy, everyone knows about this on oil, and IC on also, I think by this time, mostly we know, and its name and so on. This is the that is the involvement for this protocol and so on in power and energy system. That's why IC 61850 communication network and system in substation is very important. So far, substation, I think someone you may already notice that I mentioned previous slide, IC 61850, then X and Y. So that is coming with the extended like a corollary, and then a station bus, and then because coming with that IC 61850, 81 is substation bus, and then 9 that is the process bus. So far, then also there is high availability redundant networks. This one also IC 6249393. So this one, of course, coming in link with the ICs on, and my student worked on this. If the time permits, maybe last day, I will show some of the results. That one I did not send to you. So that one also someone may ask the question. That's why I am keeping that one as pending, but that one we can discuss at the last time. Okay. So then there is the PRP, parallel redundancy protocol for redundant start architecture, and then high availability seamless redundancy protocol, HSR, is well known for redundant ring architecture. Okay. So these are also some of my, for this specific number, my student also published some of the works, and that is also available in Google Scholar or Scopus. If you put my name, it will come with that name. If any further question about that one also can be shared. And whatever student did, that presentation also, I will try to share the last date. And then that is application oriented. Currently he's working on this topic. So far, this IEEE, then C37.118, this is a phasor measurement. Even we know phasor measurement unit. So precision time synchronizing, IEEE 1588, and precision time protocol also there. So, and then also we need for our server and power and energy everywhere, security is required. That's why cyber security also important. So in that case, IEEE and IC, they are also working together, and that's why this information, any RC, CIP, IEEE, IEC, there are different, and then many working nowadays, cybersecurity, physical layer, and so on. That is related and important for our power networks. So I'm not working on cybersecurity, someone also want to do, but I said I cannot expand too much, maybe future, not at this moment. Okay, so that one also very important. And then just as a benefit of IC, what sort of benefit? We know IC. So what it can do, I will explain this on, otherwise what is the point to use it? If I don't know the benefit, then it is not useful for us. We should know. So what sort of benefit there? IC, you can see, this is a simple name. If I start from here, what is this? More capability and flexibility. What I said, how many messages we can transfer in 50 milliseconds? Very big number, right? If you cannot remember, I can show you here. Goose can send 10, 50, 150, 300 good messages within 50 milliseconds. So application oriented, I think IC is beneficial, more capability, more flexibility. As I said, it can be expandable. Possible extension will come. It is possible from here. Okay, and the reduce setup and configuration. Of course, reduce. You have seen the substation, it will be miniaturized and less occupancy of the space and area and weight also. More interoperability is here, it is possible. And then initial little bit difficult, but installation cost is low for long life. Reduce manual efforts and errors. What type of manual efforts and errors? Professor Bhardas, yesterday, someone asked about the copper, and we don't need too much copper wire share cabling. All Ethernet will use, and then we'll be in a compact form. So manual connection, copper wires not necessary here. That one, I think inside the slide is there. And then less error possible because the system is mostly digital, and then it should not be any issue. As we have seen the footprint of substation, that one is very much compact and works are very much limited over there. So in that case, it is beneficial, and that's why I say this slide's name is Benefits of IC 61850. So that is important. And then there is a self-describing devices. Even you are getting good messages, they'll describe about their all information is there, and then messages coming is alarm system will write on your screen what is there, what sort of information, and then there is naming convention that will say object naming convention is there. It is useful, and then you should not be confused about that on, and it is easily can be identified. So naming convention facilities over there, and then standardized communication. Sorry, someone called me. Then standardized configuration is available. We are using the global standard, different vendors, but that one is adaptable and acceptable, globally can use. Like, as I said, ABB, Siemens, Alstom, and then G and other companies. So far, as I said, my student doing some experimental work. When I was at Curtin University, we got heavy support from industry, and they established the IC 61850 lab at Curtin University. But I left that university, but the student is still working over there. So need collaboration with industry. They should use this, and then they can give us feedback, and we can improve our design, measurement, simulation, modeling technique, what is possible. So we need interlink between industry and academia. So this standard configuration is there, and modern network, that is on modern network system and smart grid, everything's are there. It could be actually not only the ring, not only the star, it should be a hybrid system, right? And then standardized device and object models. So everything is over there. This is something noise. So it is standard and globally, and then its model is useful. So overall, mostly benefited, and we can use it. Okay. So far, there are lots of benefits, even not explained here all, but need good background. That's why I discussed today a little bit the DMP, RS 232, RS 485, and so on. How we came DMP 1, 2, 3, how, and then UCA, and how we can manage. Okay, Professor, time mostly finished, so we have to stop here.
Yes, yes.
Okay. Thank you, Professor.
Continue.
So anyone, any quick question?
Any question from any person? They can ask. Yeah. Or Madam Shweta, you can conclude the session.
Okay, sir.
Any question from anyone?
No question.
Yes, ma'am. Please.
I hope I am audible, sir.
Yes.
Okay. I would like to ask from the participants, if anyone have any question, then please keep it here so that else we will conclude our session, this session.
Even if not today, pass the question to Professor Bardwas, and then I can get email, and then I can respond also. So don't feel any shy. If as I said, that things I'm a little bit confused, so I will prepare and respond back. So because we are learning, and interaction is very important to learn.
Definitely, sir. Yes. Okay, sir, first of all, I would like to thank you for this session, and we'll definitely looking for much more sessions from you. We are having that. So first of all, sir, thank you very much for this informative session, and whatever is left, that definitely will be covered in the next 2 sessions. We already have next 2 sessions with you. Sir, yes, thank you very much for this session. Okay, and yes, sir.
So that one is on not tomorrow, Thursday and Friday. I think yes, that sir, one is in the program.
Yes, sir. Same time, Thursday and Friday, we'll have you here, and it's really nice to listen to you, sir.
Okay, thank you very much. But if it is a longer time, I can speak more slowly, but it's a little bit rushing. That is problem, but no problem, because anytime anyone want to contact with me, I can send my common Zoom link That is from university, only dedicated to me. Anytime anyone can contact, but I will pass it to Professor Bhardwaj, and then our email also will be fine. So happy to share my knowledge and expertise, whatever I have. Even happy to get the questions where I have the lack. So I have to understand and then share my knowledge with like academia, industry, or research community. That is the, I think, main purpose of this workshop arranged by Professor Bhardwaj.
Yes, sir. Thank you very much for that. This also, sir. We will forward your mail ID to all the our participants so that they can contact with you personally, and they can make a queries also, whatever they wish to. Okay.
I think
sir,
I said, ma'am, I already said to Professor Bhardwaj, can share the slides also. File with Professor Bhardwaj.
I have already shared the slide to the department.
All right, thanks. That's good. Because if I don't share, then what is the point? Even though when I attend other workshops, I ask them, because instantly talking about an hour, we may forget. If further query, like a mini book, they can ask question, read and ask question. That is also supportive to them. So I want to help them.
Okay, thank you, Professor. Thank you very much.
Thank you, Professor Bhardwaj. Thanks, Shweta ma'am, for
your
introduction and explanation. So we'll meet again on Thursday at the same time.
Yes, sir.
So then you'll send another new Zoom link, right? Every day new Zoom link.
Yes.
Yes.
So we have tomorrow on, but tomorrow's on. Yes, you can send tomorrow's on. If I have some time, I can join. Otherwise, send every day. Then so far I will try. I also very happy to meet with Professor Bansal. Is a very good collaborative friend. We are in the we organized conference together before. That's why he mentioned happy to see you. That is also very good and connecting people.
Yes,
every day I will send you the Zoom link.
Okay, thanks,
sir,
Professor.
As per Indian time, you will get the Zoom link either same day in the morning or maybe just a day before at night.
Yeah, no problem. That one, Professor Bhardwaj already explained to me, and I set up in my computer. Otherwise, I will be missed out. So that one, he spoke with me over phone and set up this. That's why I'm popping up very close to that time.
Thank you very much, sir.
Thank you.
Okay.
All the best.
I would like
Namaste.
to thank to all my participants also for joining us for this session. We are having a lunch break now, and our next session will start at 1:45 p.m. So thank you, everyone.
Okay. Thank you.